Hi, everybody, and welcome back to video number 5 in Chapter 5. And when we left off, we were looking at computing a future value for Mr. Goodwrench. He deposits $2,500 today in a savings account and earns 9% interest. He plans to deposit that every year for a total of 30 years. How much is he going to have? Now, we know we need to adjust for that fact that he deposited it today. So let's take a look. To create his retirement fund, we need to go into the future value of an annuity, and we're going to find that on table 5.3, and we'll find it here, 136.30754. But we need to adjust that for one more period because he deposited that today instead of waiting a year to deposit that first deposit. So we'll multiply it times 1 plus the interest rate, in this case 9%, and that gets me to 148.57522 times 2,500. That gives me 371,438. So he should consider maybe putting more than $2,500 per year into his retirement account. And of course, he would build up much more money that way. This is a very valuable problem for us, both as business people, but also personally, because we all need to plan for our retirements. Okay, so now we plan to accumulate $14,000 here for a down payment and on a condo 5 years from now. So for the first 5 years, you earn 8%, this time compounded semi-annually. So I now know that I need to multiply these years times 2 to get 10, have this 8% annual rate to get to a semi-annual rate. So I'm going to go look up in the 10 period at 4%. That gives me 12.00611. We divide that through. We get $1,166.07. And as I look on this next slide, you'll see that amount, that item right here, 12.00611. Okay, so now a company wants to accumulate 117,332 by making periodic deposits of 20,000 at the end of each year, which are going to earn 8% compounded annually. So we don't need to adjust for semi-annually, and we don't need to adjust for an immediate deposit. So all we do is we take the 117,332 divided by 20,000. We get 5.86660. We go into table 5.3. We read down the 8% column here, and we find that that factor hits the 5-period row, in this case 5 years. So they must make 5 deposits of 20,000 each. That totals $100,000. And they earn enough interest to crank that beauty up to 117,332. Okay, let's look at some independent situations. Here, the future value of 20 periodic payments of 5,000, each made at the end of each period and compounded at 8% here. That one's pretty easy. We just go into the table 5.3, look up the factor, multiply it through times 5,000 to get to 228,810. Pretty easy there. The next one, however, a little different. What is the future value of 15 deposits of 2,000 each made at the beginning of each period and compounded at 10%? The future value as of the end of the 15th period. So we do need to make a adjustment here because that 2,000 was made at the beginning of each period. So what we do here is we go into the table 5.3, pick off this factor here and multiply it times 2,000 to get $63,544.96. Then we multiply that times an additional 10%. And that gets us to 69,899. And as you can see, that was 10% interest here. Okay, so Steve Malpese needs $250,000 in 10 years. How much must he invest at the end of each year at 5% interest to meet his needs? Well, Steve is going to need to take that $250,000 and divide that through. We have 10 years, 5%, right? And that factor is going to be 12.57789. We'll divide that simply into 250,000. We get 19,876. That's how much he needs to make as a deposit each period. Okay, whoops, let's go back to Delta here. Joe Morgan is investing $9,069 at the end of each year in a fund that earns 5% interest. In how many years will the fund be at 100,000? So what do we do there? What we're going to do is we're going to take this $100,000, and we know that it's going to be this $9,000 times this rate. So we're going to divide this into 100,000. We get 11.0266. We look this up in the table 5.3, and we find that that's going to hit about 9 years. Okay, let's take a look at solving present value of an annuity and an annuity due problems. Here, we're going to assume that the dollar is received at the end of each of the 5 periods as separate amount and earns 5% interest compounded annually. Aha, so this is our normal situation. And if we wanted to calculate that out, we can just simply add from table 5.2 these factors to get to 4.32948. And that's the present value of an ordinary annuity, 5 periods at 5%. Now, what we're going to do is, if you like this formula and it makes it easier for you to understand, great. The present value of an ordinary annuity. So what we're going to do, if you wish to determine the value today of receiving rental receipts of $6,000 each at the end of each of the next 5 years, discounted at 6%, what is the present value of those future receipts? Well, that's an easy one. We're just going to go into the table 5.3, pick off this factor, that's 5 periods at 6%, and multiply it through times 6,000, and that'll give us $25,274.16. So that's pretty easy. And to determine the present value of an ordinary annuity factor, we just simply refer to table 5.4 for 6% column and 5 rows. Okay, now let's do another one here. In this case, Lucky Louie has just won the state lottery, $4 million. He learns that he will receive a check in the amount of $200,000 at the end of each of the next 20 years. What amount has Louie really won? That is, what is the present value of 200,000 checks he's going to receive over the next 20 years? Assume that the interest rate is 10%. Okay. So what we would do, let's make sure that this works this time. We're going to go into the present value of an ordinary annuity. That's table 5.4, not table 5.3. And we're going to go look up for 20 years at 10%. And if I do that, I do find exactly that 8.51356. So simply stated, I divide the 200,000 here by 8.513356, and we get 1,702,712. That's how much he's really won, not $4 million in present value terms. Quite a bit of difference between 4 million and 1.7 million, right? Okay, so now we're going to take a look at these. Here's our ordinary annuity in table 5.4, and it shows the rates you see in table 5.4. But if I go into the next table, this is table 5.5, you can see that we're starting here at the beginning of period 1, whereas here we're starting at the end of period 1. And those are different rates, as you can see. So you really got to know when those annuities come due. Okay, so here's an example of an annuity due. Space Odyssey leases a communication satellite for 4 years with annual rental payments of $4.8 million to be made at the beginning of each year. If the relevant annual interest rate is 5%, what is the present value of those rental obligations? So now you can see that this is starting period 0. This is going to be annuity due. So we're going to go into 5% and 4 periods. So let's look at that. 5%, 4 periods. And that's going to be, in table 5.4, that's going to be 3.54595. And we adjust that, we adjust that for one more period here to take it to 3.72325 times the 4.8 million gives me 17,871,600. So if Space Odyssey has a table with a present value of an annuity due, we can simply locate the desired factor 3.72325 for 4 periods and compute the present value of the lease payments that way. Okay, is it starting to make sense? I hope. And then shoppers commonly use credit cards to make purchases. When you receive a statement for payment, you may pay the total amount due, or you can pay the balance in a certain number of payments. For example, assume you receive a statement from Visa with a balance due of $528.77. You can pay it off in 12 equal monthly payments of $50 each. So with the first payment due 1 month from now, okay, what is the rate of interest that you would be paying? Okay, so what we would do is we'd take the $528.77 that you owe, divide it by the $50, and we're going to have 10.57540. We're going to go into table 5.4, and reading across, we're going to find the 10.57534 in the 2% column. Since 2% is a monthly rate, got to watch that, 2% is a monthly rate, we're going to need to multiply that times 12 to get 24%. And if I wanted to really calculate the effective annual rate, it's going to be 26.82423%, calculated as follows. Pretty interesting. Okay, that looks like a pretty good spot for us to stop this video. And when we return, we'll take a look at Norm and Jakey Reamers. Until that time, bye for now.